the second method, slope-intercept method, you get these bits of information, and this method is used when y is alone or isolated. Y is isolated on one side of the equation when y is isolated. And so that form would be, and this is called the slope-intercept. This is called slope-intercept form, hence with the name, and that form is y equals mx plus b. So it's telling you who the slope is, and it's telling you the y value for the intercept point. This is the y value. B is the y value for the intercept, y-intercept point. So that's 0, comma b, because we need a point out of it. And that's just one number. We need a point to get to the Everybody clear on that part? Good? And the m is your slope, but that slope represents changes, change in y, so you need m to be a fraction. M has to be a fraction. If it's not a fraction, you make it a fraction by putting it over 1. Because you need two numbers. You need the top number and the bottom number. You need the definition of that slope. You need those two numbers, and you're going to use these two numbers to get point number 2. You have point number 1, but you need point number 2. But you're going to use the slope to get them. We're not going to go on the graph. We're not going to do that. You're not going to be counting 3.46. You can't do that. You can't count 3.46. You're not going to be able to get that. So that's why you don't use your fingers anymore. Remember what they had you do in high school? Had you use your fingers and count over this way, go up and go down, and all that jazz. You don't do that anymore, okay? And so, because we're not going to use our fingers to get the second point, we're just going to take these changes and we're going to add them. Because that's what they are, changes. So if I add the changes, I get the new location. And if you want to understand how that works in the real world, well, think of the car you're driving the car. Think of your speed. If you're at mile marker 120 and your speed is 50 miles per hour, what's the change, or what mile marker will you be? You 1 hour. It's 50 miles per hour and you're at mile marker 120. What's your new mile marker going to be in an hour? 50 plus 120 is 170. That's because you added the change to where you currently were sitting when you started. You added the change, now you get your new location. Does that make sense? That's what's happening here. This is the change. So if I take that y and I add it to that b, that's going to be my change in my location. Now, what's going to be the change in the time? Whatever this time delta is, I'm going to add it to 0, because 0 means at the start, my initial. So add that change in y that it took me to travel that distance, and then add that to 0, that's my new time. That it took that I will be at that new position. Does that make sense?
Mm-hmm.
So that's an application of a physics application, and it's not even a physics, it's normal life. We drive cars. So you're looking at a slope. And if you're going to tell somebody where you want to be ahead of time, and you're doing that speed, you can predict where you're going to be ahead of time if you maintain that speed. You're going to know where you are. Does that make sense?
Yes.
So that's using a slope to get a new location. Everybody following? So that's the concept of what we're doing to get the 2 points so that we can connect the path, and then the line is the path that you're taking. Does that make sense? So we got 2 methods. One uses a slope to help us get to point number 2. But the nice thing about this method, slope-intercept, is this information is staring at you. There's no work to do there. The only work is to get the numbers added to that, and that's the work. But the numbers are there. Whereas this method, you have to do work to get these points. They're not staring at you. You've got to do a little bit of division. But it's not hard, you see? Okay, I'm going to use the intercept method because this is standard form. So, and C is not 0, so I'm supposed to use this method on this. That's why we have the 2 methods. I'm not supposed to use this one because Because if I have to use this one, I've got to do a lot of algebra before I can use it. I've got to get y alone, which means I've got to move this guy over here, then I've got to divide everybody by 4 before I can use it. Why would I want to go through all that work? That's why we got 2 methods, so that you don't have to do that. See what I'm getting at? But some people like the slope method, so they don't care that they have to do extra work, because that's the method they like. Well, if that's what you want to do, then yeah, go ahead and do it. But the odds of you, or the chance that you're going to make a mistake, like a negative sign mistake, very high. Because you got to move this guy. If these guys have negatives, you got to make sure you handle the negatives. You got to move this guy over here, then you're going to divide everybody by this. So that you have more opportunity to make a mistake. You want to lessen that opportunity to make a mistake. That's why we have the 2 methods. You don't have to do it.
Which method do you prefer that will be easier for us?
That's what I was just saying. It's not what I prefer. It's what these methods were designed for. This method was designed for this type. That's what it was designed for. It's not what I prefer. What I prefer, that's what I just said. If I prefer this one, then I'm going to have more work for me.
Oh, yeah, you did. Okay.
Designed. You see what I'm saying? This method was designed for this.
Okay.
For that form. Does that make sense?
It does.
So it's not a matter of which one do I like. I mean, you can still do it, but it wasn't designed.
Right.
Does that make sense?
It does, yes.
Right,
Thank you.
So, this is standard form, so I should use the intercept method because it was designed for that. So that's what I'm going to do. Now, I remember that one question in Pearson where it gave you this form, but it said to use the intercept method? So they were tricking you. They were tricking you to see what you would do. I did exactly what they said to do. I used the wrong form. And you saw how much work it was on the paper.
Mm-hmm.
And I did that intentionally, because that's not the form, and I wanted to show you, it's more work, more opportunity to make a mistake. It's not what should have been done. I should have just moved, if they wanted the intercept method, I should have moved the X guy over to the other side. Then I used the appropriate form, and it was quick, fast, easy, less chance of making a mistake. Okay? So, this method, intercept method, says, let's find these 2 points. And these points are the easiest points to find because one of the letters is 0. And when one of the letters is 0, 0 times anything is 0, that guy is gone. So I don't even have to bother writing it down. So if y is 0, that means the y guy, he's not here. So only the x guy. So I'm just going to write the x guy, ignore the y guy, and keep the 8. And then I solved this for x. The one letter, and that's why I did the numbers to be nice. I'm not worried about numbers here, I just want the concept. So x is equal to 4, and so then you put that 4 back into the point. So now we have 4, 0. That's the x-axis on the 4 tick mark, on the x-axis. This is on x-axis, tick mark. Let's go. That tick mark, T-I, like a T-I-C-K, tick mark. Or is it just T-I-K? I don't know if it's
T-I-K.
I think it's T-I-K, tick mark, huh?
She talk about it.
I don't know.
I don't think it's standardized.
Like tick-tock, and then tick-tock.
Exactly.
I see like tic-tac-toe.
Yeah, tic-tac, tic-tac, tick mark, I guess, yeah. What, I've never, is that actually a word,
Do
tick
we
mark?
even need to
It
know
is.
that?
Can you look it up? Yeah.
Okay, so
Tick
x
mark.
equals
The little
8
tick
over
mark is
2.
number 4.
8 over 2, which means x equals
No, that's
4.
maybe it's not a word.
Tick mark is not a word, maybe they just made that up. Okay, it sounds.
Okay, and then on the other side, we're going to say
Okay, yeah.
4y
T-I-C-K.
Oh, I had it right.
Yeah.
Oh my God.
Yeah.
That's a first.
divided by 4
Usually my
divided
spelling is
by
the worst. I'm like the worst.
12.
But yeah,
I really don't have to write that because it's kind of easy, so
Yeah. But, like, I say tick mark.
it's going to
Easier than doing the CH.
Okay, so
x equals
is this how you spell
4.
like a tick? This is how you spell like a tick?
Like a bug?
It's like tick, yeah.
Really
All right, so the
technically,
x-axis tick mark 4, and mark 4 on the row.
8 over
okay? So that's, this is on the x-axis, so that's that one. This one, who's gonna be 0 out of the picture? The x guy, so the 4y guy is in, and whatever sign he is, don't forget to bring the sign down. But he's positive, so I don't have to show it. Y is equal to 8 divided by 4, so y is 2. So 2 goes in here, 0, 2, so these are the 2 points. And this is on the y-axis,
So
1, 2,
x
tick
equals
mark,
2.
2 up. So this guy's on the y-axis, this guy's on the x-axis.
Okay.
You put the 2 together on 1, 2, 3, 4, right here, and then 2, right here, here's 2, here's 4. Put it, and then you just connect the 2 dots. That can't be any easier, right? Right? It can't be.
So it's just one, oh no, there's two, okay,
Points. Yeah,
got
you
it,
have to have
2
2
points.
You can't just have one.
Okay.
Some people make a mistake, Angel, and they take this 4 and that 2 and they put it together and make a point. No, don't do that.
Okay,
You have to have 2 separate points, and one piece of that point has to be 0. They have to be the intercept. If you take this 4 and this 2 and put it together, that's not an intercept.
no,
It's not on an axis. It's not on an axis, you don't do it, you don't apply it, okay? Does
okay,
that make sense?
yes.
Everybody good on this method?
Yes.
It's very easy peasy when you just, like, keep it simple. All
Okay,
right, now let's go for this method right here. What if I have, y is equal to negative 1 half x, and then I have a plus 2, okay? So I want to graph this. What form is this line? What's the name of this line? Slope-intercept form, because y is solo. Are we following the difference in the form of the line? So when y is solo, when y is isolated, this is called slope-intercept form, and the information, the numbers that I see, that's information I can graph. So what I do is right underneath it, I just write the formula that represents that line, and then I graph. I'm grabbing everything in front of the x, and then I grab everything after the x, including the sign. So my m is equal to negative 1, and then you got to give the negatives on the side. You have to give it to one of the numbers. Which number you give it to does not matter. Just don't give it a both. If you give it both, it's fine, positive. So I'm just going to give it to, I always give it to the top. I always give it to the top, because I don't like denominators to be negative. So it's negative 1 over 2. So the top number is my change in y. My bottom number is my change in x. And I need those changes, because I'm going to add those changes to this point. And then my b is 0, 2. Here's the y-intercept, here's the y-intercept. Because that equation is actually this one changed. Okay? To the same. Once I just isolated myself. Okay? So show you that the same, it's going to graph. It's going to be different points, but I'm going to graph. So 0, 2 is one of the points, and then if I take this y and I add it to here, and I take this x and I add it to here, I get my new one. So I'm going to add 2, and I'm going to add negative 1 to this. So my new point is 2, 1, because I subtract 1 from 2, so 2, 1. I add 2 to 0, and I take 1 away from y. Take 1 away from y, and I add 2 to 0. Okay, now watch. If you use the tick, if you use the arrow, okay, that, Lisa, is that right? Did I get your name right?
Yes, I have one question.
What?
When you pull down from B, is the 0, 2.
The b is the 2.
And it's always going to be 0, whatever.
Yeah. And do you know why, though? What letter is this 0 representing? Okay, if you put a 0 in here, what happens to this?
It goes away.
It goes away. And
Okay.
what y becomes? You following? You see, it'd be nice to know why, because then you know. Yeah. Okay.
So it's the same thing as what we did over here with the other probable.
Yeah. You 0 in here, and you just get the y. By itself a y.
Okay.
Okay? It's not that bad, right?
No.
All right, so now, which numbers, Lisa, what numbers are we going to add? How do you want me to show you how to add these numbers here?
You can do it the way that's
The
on.
arrows are okay?
Yeah.
You understand the arrows? All right, so I'm going to take this negative 1 and I'm going to give it to here. I'm going to give it to here. I'm going to take this 2 and I'm going to give it to, so the bottom goes to the x, the top goes to the y. That's why I say change in y, change in x. Okay? Then I'm gonna add the 2, add the -1. So what's my new number gonna be, my new point? 2, 1, because I subtracted 1. So now you have this point, 2 points. And this is not an intercept. That's why this point's not gonna match this one, because it's not an intercept, it's just a point. But I'm gonna get the same line though. So now you're gonna have 0, 2, 1, 2, because this is on y-axis, 2 up. So that's 0, 2, and then I'm gonna go 2 on the x and then 1 on up. 2 right on the x, these are directions. 2 to the right and 1 up. 2 to the right, 1 up, right? Look at that song, to the left, to the left. Yeah. Every time I hear that song, I'm always thinking of graphing. To the left, in the box to the left. I don't know what the rest of the song is. Something about keys. Okay, I think it's
Beyonce.
keys.
That's Beyonce. Beyonce.
But keys are in the lyrics. Something about keys. Like, shouldn't she go?
Drop them keys.
Oh, yeah.
Yeah.
Oh, that's what it is. Yeah, all I think is to the left. And every time I think that, I was thinking graphing.
Wow.
Right, 2 to the right, just 2 to the right, 1 up. Okay, so 2 to the right, 1 up, right? 1 up is right here, 1 up, and then if we connect those two, and this would be number 4 if it was going, if I had my ticks marked correct, if I had my tick marks correct, that would be 4. If this is the point, this is number 2, 2, 1, and so that's the 2, 2, 1, and this is 0, 2. Okay? 0, 2, and that's 2, 1. Everybody all right? And that's the same line as this line. It's the two different points. All right, so what do you think of the two methods? You think you got it? So graphing is not hard. Not hard if you understand what's going on. It's only hard when you don't understand. But when you understand what's going on, it's not hard. But you have to make sure that you write down, what the whys so that you can relate to it so that it will be easy to do. If you study or memorize just because you don't understand what you're memorizing, you're just mimicking, sometimes mimicking will get you through. It'll get you to pass the test. But to retain the information long term, mimicking does not help you with that. It's only short term. Mimic only helps short term, not long term. Long term, you have to understand it. You have to understand why and relate to it and keep that information for a long time. So it depends on what your goal is as to how you study is going to impact your future in terms of do you need this. And I can tell you you're not going to be graphing lines like this, but you are going to be doing similar concepts in terms of grabbing, working with things. You are going to be doing that in your field when you get to the math portion of your field. You're not per se like this, but that whole math behind grabbing something and doing something with it, that you will be doing. So by just practicing that concept of being able to grab a number, use it for something, is going to help you. It's not going to be in the same context as this, but it's a skill that you're going to need, that your brain recognizes the skill. It goes, yeah, we did it before on a different situation, but yeah, I did that before. I'm able to grab things and identify and do something with what I'm identifying. So that's knowledge, that's math, that's exercising your brain on that task. So math does help you, even though you're not going to be doing this and that. The technique, the process does. All right, so that's graphing. Now the definition of a slope, M. And remember, M is a ratio. Ratios are written like this. When you say ratio, if I said ratio, a ratio is like this, A to B. That's a ratio. A ratio is not written as a fraction. A ratio is two numbers with the colon in between. That's called a ratio. But when you write a ratio are fractions. Like this ratio is kind of like used a lot in different fields. Like for example, the pitch of a roof is provided in this format. So they say the pitch of your roof is 3, and this is the word 2. 3 to 2. So if someone says your roof is 3, and they don't use the word 2, they go 3 to 2, what does that mean? Well, they have to put the units like 3 feet to 2 feet. Well, what that means is that this is always your up or down, and this is always your left and right. So this means 3 feet up for every 2 feet right. 3 feet up for every 2 feet right. So if your pitch is 3 to 2, that means 3 feet, your pitch is going to go 3 feet up for every 2 right. That's your pitch of your roof. And carpenters understand that terminology. They understand what that means, okay? So this is called ratio format. But ratios can be written as a fraction. This is the numerator, and this guy is the denominator, so that's hopefully understood. And this is how a slope is. A slope is your change in y, which is up and down. The up and down comes first, and then the change in x is the left or right and bottom. So your slope is up and down, left and right. These are the two changes in those directions. That's what a slope is. And it's the change from here to here, and it's the change from here to here. So it's a change along the x, and this is the change along the y. That's what a slope is. It's a ratio of changes from one location to another location. The change that took place. So if you're at mile marker 120, and then I'm mile marker 170, and it took me 30 minutes to get from here to here, then what was my speed? If it took me 30 minutes to get from here to here, I went 50 miles in 30 minutes.
100 miles an hour.
Yeah. I did 50 miles in 30 minutes. So the change in here to here, the change in y is 50. The change in my time from here to here was 30 minutes. And you make a fraction out of that, 50 over 30, but this is units, is minutes, that's miles. And we don't give speed in minutes, we give it in hours. So to change this to an hour, I can multiply it by 1 and disguise of 2 over 2. 2 times 30 is 60. But whatever I do to the bottom, I have to do the top. So that would technically have been 100 miles per hour. I was going 100 miles per hour. I was able I was able to travel 50 miles in a half an hour. Because I was going 100 miles per hour. Following that? So the change in your distance that you traveled and the change in the time that it took you to travel that distance, you make a fraction out of that, that's a slope. Anytime you make a fraction of two changes, no matter what those changes are, they can be things growing in a petri dish, they can be whatever two things you're looking at and you're relating it to. And if it's a change that's going on with those two things and you make a fraction out of those two changes, it is a slope. But it's a slope in the real world. So you don't see it as X or Y, you see it as whatever the two things you're feeling, like heart rate or something like that. Or how about the blood pressure? Now blood pressure is different. Your blood pressure,
It's just historical like that.
yeah, but when they measure that, it's not a change, it's just what it is at that moment. You see, so that's not a slope. Because it's just what the number is at that moment. It's not a difference between the two. You know what I'm saying? Not like your heartbeat, right?
Beats per
Well,
minute?
it's the
Beats per
first
minute.
beat you hear when you're taking a blood
Okay,
pressure.
okay.
The first beat is
you
the
hear.
first number.
Okay.
The last beat is the lower number.
Oh, the bottom is the lower
Yeah, so
number.
it's kind of, yeah.
Yeah, so a kind of, so if you look at the difference between those two things, so 120 over 80 is considered what? That's not really normal.
It is, 120, well, 80 is a little bit high, but yeah, it's still big. Now they're saying it's normal to the
All right, so the
It's
top
gonna give you
number,
a
the top
stat.
number is your,
Systolic.
but how do you calculate it?
So the top number is, the highest beat per minute.
The highest,
The
so
highest
in other
beat.
words, it's looking at all the beats in a minute, and it takes the highest number.
Yeah.
All right, so that's
So
not
you-
a change.
When you blow the cup up, it
Yeah.
cuts off circulation.
Yeah, because of circulation.
So when you cut off circulation, you hit a thump.
Yeah,
That's the first number you document.
okay, that's because.
And then you keep your eye on it, and as the thing comes down, it bounces all the way
Yeah.
down, so
Uh-huh.
it mimics the heartbeat.
Yeah,
And then when you
Yeah.
don't hear that last whoosh, that's you know, you've got.
So that number is when it releases,
Mhm.
and you don't hear it to beat
Right.
anymore. So it's actually telling you how long your beats are really.
20 years ago.
So the difference between those two numbers can significantly imply something in terms of your heartbeat, right? And if your
Yeah.
heartbeat takes that long to.
Well, yeah, because that's how hard your heart is
It's
beating.
beating, yeah,
Beat
yeah,
that
so
blood
it
through your body.
does give you some information, but those numbers themselves are not changes. Hence, the blood pressure, even though it's a fraction, is not a slope.
Right.
See, the
No,
numbers
it's
that it
not.
represents has to be the changes. So when you say heartbeat per minute, you're counting in 1 minute time how many beats. So you're starting, and the clock starts, then you go 1, 2, 3,
Mhm.
4, and then within a minute you count all the beats. Well, usually you don't wait a minute, you just do 15 seconds and
Yeah.
you multiply it by 4,
Mm-hmm.
right? Because you're thinking it has a pattern.
Right. that's
But
if
once
you're
you
doing
start counting, and that clock starts, that's a change. From this time to this time, that's how many beats have occurred. So the number of beats is a change in start to end. And then the amount of time that you measured that's the denominator. So yes, beats per minute is a rate, that's hence the word heart rate, right? But your blood pressure is not a rate, even though it's a fraction. So that's why the numbers that you see have to represent a change in something in order for that fraction to be called a slope. So not all fractions are slopes. You follow me? That number has to represent a change in something in order for that fraction to be called. Now, do you understand the difference between a fraction versus a slope fraction?
Yes.
Yes. That's what I wanted to point out, because there's changes. Okay. So hence the definition for M. M is the change in Y over the change in X, and change in Y is your second Y, because there has to be a difference over the two X's, because there has to be a difference because they're changes. Okay? Any questions on the definition of a slope? So now when you take your physics class, for those of you who have to take physics, and they talk about speed, then you're gonna know it's a slope. And if the